Hello everyone, welcome back to the next video. So improve your app with real-time metrics. It takes too much time to see the result of an action. Profiling is essential to understanding the runtime performance of the app through analysis that measures the memory or time complexity, frequency and duration of functions, function calls, etc. Getting all this information helps you track down and provide proper solution to keep your app healthy and your users engaged. Xcode provides some basic tools to do the first report. You can monitor CPU, memory and network. CPU monitor measure the amount of work done. Memory monitor is for observing the use of app. All iOS devices use SSD for permanent storage. Accessing this data is slower compared to RAM disk. Monitor is for understanding your apps. This writing performance. Network monitor analyzes your apps, iOS apps, TCP, IP, UDP, IP connection. You can tap on each of them to find more information. It also provides an extra monitor that isn't shown by default, but can help you inspect your UI. It's a view hierarchy. While the app is running and you are on the screen you want to inspect, click on debug view hierarchy. This will help you to detect overlappings. You can't see a component, or if you want to flatten your component tree, even though React Native does a view flattening, it sometimes can't do it with all of them. So here we can do some optimization focusing on specific items. Let's say we have a to-do list of, and when the add button is pressed, it adds a new item to the list. However, it takes a couple of seconds to show up on the list because there is some logic before the item is added. Let's go to our dev toolbox and pick up our first instrument so we can confirm and measure the delay. iOS instrument is a debugging and profiling tool that comes pre-packaged with Xcode and is literally a box of tools, each of them serving a different purpose. You can choose from a list of templates and you can choose any of them depending on your goal: improving performance or battery life, or fixing a memory problem. We are going to use Time Profiler. Let's dive into it with Xcode open. We go to the open developer tool, instruments, and scroll down to find the Time Profiler tool. It will open a new window. To start profiling your app, click on the drop down menu and select your device and the app. When the app opens, start using it normally, or in this case add a new to-do item. After playing around and adding the new to-do item, we can see there is a big blue rectangle, which means there is something that is taking a lot of time to finish. Let's take a look at the threads. You can expand by pressing option. Click over the chevron, which will expand to display useful information. At least for now it is showing the memory address, but we will need to find another way to find where the problem is. Combining with a tool specific for JS context tracking, let's use Flipper, the same one that we used in pay attention to the UI re-renders, but we are going to use another monitor called Hermes Debugger. With the app open and running, we go to Flipper, select the running app if not selected already, and go to Hermes Debugger. React Native Profiler, we click start, so the profile begins. We do the same flow and actions as before. When profiling with Time Profiler, when we stop, we will see all the data collected. By default, the data will be sorted bottom up with heavy task. At the top we can see that a function called doFib is taking 14 seconds to complete. It's a good start. Let's go into that function. Let's see what we can do. The fixes will vary depending on your code. After applying a possible fix, we first check the Time Profiler. Again, we click on the record button, start using the app. In our case, let's add a new to do item. As we can see, the fix we applied did work. We aren't seeing the big blue rectangle like before. This is a good sign. Let's continue with our profiling part to check how it looks in Flipper. Start profiling the app one more time using Hermes Debugger. React Native Profiler, we don't see the doFib function anymore. Only other expected React Native task benefits having a faster and more responsive app. 70% of the user will leave the app if the response to a given action takes too long. Profiling our apps has become one of the main steps in our development lifecycle. Using specific tools like Time Profiler will help us understand if our app is responding fast or where we could find areas of improvement. Remember, users are becoming more sensitive to speeds and delays. Even a 0.1 second of improvement can increase a conversion rate of 10.1%. Know how to profile Android. Get real-time metrics to better your app understanding. You encounter performance issues that come directly from Android runtime. In the event of any performance issue, we mostly use React Profiler to troubleshoot and resolve our problem, but since most of the performance problem originates from the JS RAM, We don't usually need to do anything beyond that, but sometimes we will encounter a bug or performance issue that comes directly from the Android runtime. In such a case, we will need a fine tool to help us gather the following metrics from the device: CPU, memory, network, battery usage. Based on that data, we can check whether our app consumes more energy than usual, or in some cases uses more CPU power than it should. It is used specifically especially to check the executed code on lower end Android devices. Some algorithms can run faster on some devices and the end user will not spot any glitches, but we have to remember some customers can use LED devices and the algorithm or function can be too heavy for their phone. High end devices will handle it because their hardware is powerful. Profile your app with Android Profiler in Android Studio. Android Profiler in Android Studio is the Android Studio is the IDE developed by JetBrains. It is officially supported by Google in the official IDE, which can be used to develop any Android app. It is powerful and contains a lot of functionalities in one place. One of those tools is Android Profiler. If you have not installed Android Studio yet, you can install it using the link to open the profiler. Choose View Tools window Profiler from the Android Studio menu bar or click Profile in the toolbar. Before you start profiling the app, please remember run the app on a real device that is affected, preferably a low end phone or emulator. If you don't have one, if your app has a runtime monitoring setup, use a model that is either the most used by users or one that's affected by a particular issue. Turn off development mode. You must be sure that the app uses a GS bundle instead of the Metro server, which provides that bundle. To turn it off, please share your device, click on settings and find GH dev mode. After that, go to the profiler tab and add a new profiler session. Wait for the session to attach to your app and start performing actions that would cause some performance issues like swiping, scrolling, navigating, etc. Once you are done, you should see some metrics like this. Each greenfield React Native app has only one Android activity. If your app has more than one, it's most likely a brownfield one. Read more about the brownfield approach here. In the above example, we don't see anything interesting. Everything works fine without any glitches. Let's check each metric. The CPU metric is strictly correlated to energy consumption because the CPU needs more energy to do some computation. The memory metric is not changing while using the app, which is expected. Memory usage can grow. Example, when opening new screen and drop. When the garbage collector GC releases free memory. Example, when navigating out of a screen, file memory increases unexpectedly and keeps on growing. It may indicate memory leak, which we want to avoid as it can crash the app with out of memory errors. The network section has been moved to a separate tool called the network tab. In most cases, this metric is not needed because it is mostly related to the backend infrastructure. If you like to profile a network connection, you can find more information here. The energy section gives hints on when our app's energy usage is low, medium, or high, impacting the daily experience of using the app. Using Android Profiler in action. In the previous example, we could see some relations between each metric. To see a more detailed view, we have to double click on the tab. Now we can see more details. When the user started to do some touch action swiping in the above example, we could see more CPU work. Each app will have its own signature of CPU spikes and lows. It's important to build an intuition about it by interacting with it and pairing certain activities like touch events with the increased usage. In other words, some spikes are expected because the work needs to be done. The problem starts when CPU usage is very high for extended period of time or in unexpected places. Let's imagine you would like to pick the best list or scroll view component for your React Native, which has the best performance on a low-end device. You notice the current solution could be revamped or improved, and you started working on this in your experiment. You would like to check how your solution works for LE devices using the above described solution. When you double click on CPU, you could spot the below data. Here you can see the MQTGS thread is used almost all the time and does some heavy computation. Because your computation are done on the GS side, you can start thinking about how to improve it. There are multiple options to check. Replace the bridge with GSI in terms of communication. To test if GSI is faster than the bridge, move some part of the code to the native side. On the native side, you have more control over thread execution and schedule. Some work to not block the JS or UI thread. Use a different native component. Replace native scroll view with your custom solution. Use shadow node. Do some expensive calculation with C++ and pass it to the native side. You can try all of these solutions and compare the effect between each other. The profiler will provide you with a metric, and based on that you can make a decision about which approach fits best to your particular problem. There's more about Android profiler here. System tracing. Using the Android Studio CPU profiler, we can also make a system tracing. We can check even the appropriate function has been called. We can triage all threads and see which function is the costliest, which affects the UX. To enable system tracing, click on the CPU section and select system tracing trace recording. After some interaction, you should see all the threads with details. You should also save your data by clicking the save button and use the data in a different row. Example, Perfetto. You also want to check the official Android profiling guide by the React Native core team. They use different tools, but the outcome will be the same. The guide provides case studies and how to spot an issue on different thread: UI thread, JS thread, native module thread, render thread, only Android. You can find more about threading models in the new architecture chapter. Flipper performance plugin for Android. We already know Flipper can be quite handy in a hunting performance issue. One of the most interesting plugin to help us out on Android is Android Performance Profiler. It can be used as a standalone tool or on CI. It can generate beautiful reports, so this tool can be used to make sophisticated experiment. Here is a picture of an example experiment. You can also automate your experience with E2E test and generate reports locally or on CI. Those reports can be used to compare solutions which is each other. Benefits: real-time metric will improve your app understanding. As stated above, users will abandon your app if the response time is too long. Using specific tool will help you understand the root causes of the app performance issues. So yeah, that's it for this book. If you have more question, you can connect with CallStack. Yeah, that's it. Thank you for watching. Bye.